Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of pgMustard. This is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, the topic is quite obvious for me, but over the last week or two it popped up several times in various places. Let's talk about overhead from auto-explain. This maybe not only auto-explain, but we can focus on this particular extension and discuss how to understand overhead and make decisions.
Yeah, I think this might be our first purely extension-focused episode, which is cool. And I know it's kind of I count it as an extension. Do you, in terms of it being like a contrib module?
It's extension, right? But like, what else? It's indeed an extension. There are two kinds of extensions. Main extensions, which are contrib modules, so-called contrib modules, old name, right? And they come with Postgres, and you can install it from official package PostgreSQL contrib. And there are all other extensions, right? Yeah. But probably we should talk about extensions separately. It's a good episode idea, maybe, right? But nice. This auto-explain, it's a contrib module. It's very like super official extension. It probably has more potential risks in terms of bugs compared to Postgres itself, but much less compared to other extensions because it's maintained by the same team as Postgres.
Yeah, that's a really good point. It comes out on the same schedule. It's shipped with Postgres, so if you install Community Postgres, you get it off by default. But it makes it that bit easier for cloud providers to offer it. They don't all offer it, but it does make it easier.
Who doesn't offer it? Who doesn't offer it?
There are a couple. Shall I name and shame? I was looking at Heroku's docs. I'm pretty sure they still don't offer it. There's a chance that the docs are out of date. I don't even think some of the newer ones, so like Superbase, I'm not sure they offer it based on their docs. Maybe that's out of date. And even there are some new ones that don't offer extensions at all.
But RDS, GCP Cloud SQL, and Azure, they all offer it, right?
Yeah, exactly. Quite a few of the other popular ones do. So should we? Maybe we should cover what auto-explain is.
Automatic explain.
Yeah, so it logs them, right? It logs execution plans like you would get if you ran explain. You've got access. Yep, so you've got access to all of the parameters. There are some minor differences, but yeah, you've got access to all the parameters you do when you run explain, and a couple of additional ones, right? So you can set a threshold so that it will only log plans above a certain duration or execution time.
It's a competitor to log min duration statement, which logs queries which exceeded. Log min duration statement logs queries after successful execution, right? Not in the beginning, as would log statement do, but when it's successful. And if duration exceeds log min duration statement value, for example, 1 second, right, or half a second. I remember, by the way, one of Postgres advantages, like 15 years ago, was that compared to MySQL, is that Postgres allowed fraction of second for this parameter, while MySQL was like 1 second was minimal value, the lowest value you can use. So auto-explain is competitor here, right? Because if sometimes people do it, you have both log min duration statement set to 1 second or 500 milliseconds, and auto-explain set to the same value. But does it make sense at all to use this approach? Because auto-explain output will include query as well, and they both log it. Upon
I thought about this. I thought about this quite a lot in the past, and I think there are some different, like subtle differences that might make it worthwhile, but you are duplicating effort for sure. One example is another bonus parameter we get with auto-explain, which is the sample rate. So because there is a small amount of overhead,
which is not bonus anymore, because log mediation statement also has this capability since Postgres 14, if I'm not mistaken. We can also sample.
So what I meant was that if we're sampling, then we might want to sample one but not the other, for example. So we might want to
that's a good
get
point.
we might want to so you understood, but so I feel like we've actually covered two of the big points. One is that we've got this log min duration for auto explain, and we can set that in milliseconds. So it's off by default. So it's -1, -1 by default, which means don't log anything. So you have to set it to something. I would heavily suggest you do not set it to 0, which will log every statement.
In many cases, it will just kill you if you do it.
Yeah, the logging overhead is severe, not just in terms of performance, but also in terms of just size, sheer volume of logs. If you
kill. I mean, the logging subsystem will probably quickly become bottleneck, and no queries will be possible to execute for Postgres at all. And we can discuss the details here. It's an interesting topic separately.
But yes, so a typical value for that on a transactional system might be a few hundred milliseconds. So it's in milliseconds by default. You can set it to 100, and that would be 100 milliseconds, or 1,000, that would be a second.
Yeah, and remember, we discussed what slow query is. And here it's very connected. So why 200 milliseconds? Because this is exactly 200 milliseconds. This is exactly when perception of human mind starts working, right? So if something exceeds 200 milliseconds, human notices this latency. So we don't want queries to exceed it in OLTP systems. And that's why 200 milliseconds. But unfortunately, in some systems, it's quite low value, and volumes you will be seeing in logs and observer effect from logging will already start hitting you. So sometimes people choose 500 or even second. It depends.
And you can change, this is something where if you're worried about the overhead, or you feel like you've got a lot of slow queries at the moment and you just want to work your way down, you could start with a higher value and reduce it over time as you have fewer of those.
This can be changed without restart. What you cannot change without restart is switching to a logging collector, which is I would highly recommend to do. But switching to logging collector requires restart.
Actually, that's a really good point. I have seen guides that suggest installing or loading auto-explain in shared preload libraries. But I think the general advice is to do it in session preload library, because then you don't have to restart to
it depends, of course. But I would, usually when you need it, if you didn't think it in advance, you don't have it, right? And it's hard to quickly, even in session, it's hard to implement it. So I would still recommend to put it to shared preload libraries, and probably even maybe turned off, or with very high threshold in terms of duration, and just be prepared to use it for some incidents. So.
By the way, would you? That's an interesting point. A high duration would mean you don't log too much, at least, but you would still be paying the overhead of running explain all the time. So maybe also a low sample rate if you were doing that.
There are multiple overheads here, indeed. Yeah. So speaking, if it already, let's finish discussing why it's useful, and then we will talk about details about various overhead things. So why it's useful? It's useful because Postgres doesn't have, we have pgMustard statements, but they log only query bodies in normalized way. So first question we usually have when we try to optimize some particularly bad query group or normalized query, we need examples. Examples can be taken from various places, but log mediation statement, slow examples from logs, it's quite good idea. But then we think, okay, we experiment in some environment. For example, it's a exact copy, or it's like, for example, database lab engine. We have a thin clone branch, and we check plan there. But then we think, maybe in reality, like a few hours ago when the incident happened in production, maybe it had this query had different plan, and we don't know, right? Maybe.
Like and you can't reproduce it, right? If you run explain,
you can reproduce it with database lab engine. You can do point-in-time recovery to go to particular point in time and like exactly in the middle of incident, and then you can use the exact same planner settings and work mem, and then Postgres should behave similarly. Like 99% it will be so. But sometimes you don't have database lab engine. Sometimes you still have doubts. In this case, auto-explain is a good way. It's a very reliable way to tell that this is what we had in terms of plan, because we have it logged, right? Like maybe the most reliable way to understand what plan Postgres used when executing this query. Right.
Yeah, exactly. And the metrics involved, right? Like, and the buffer numbers, the timings. So it's the only way.
You can choose both, none of them, or just timing, or just buffers. It's possible to tune it and choose. Yeah. And you have very good articles saying that sometimes timing overhead is not that big. But let's finish like pros of it. So to me, the auto-explain feels this approach working with actual plans feels like generation 1, right? Same as like remember we didn't have pgMustard statements 15 years ago or so, and we all used pgFuin first and then pgbadger and normalized queries processing logs. Same approach as pgMustard statements, but only for slower queries, those which exceeded threshold. And the tool normalizes them, and we have reports, nice reports. We understand that probably we don't see full picture. Okay, maybe sometimes we allow ourselves to turn on full query logging for some short period. This was considered as valid approach, understanding risks, overhead, and so on. We turn it on for some minutes just to collect whole iceberg, right? And then we have a query analysis. But without plans, right? We never saw plans there. But then pgMustard statements replaced this approach almost, because like, okay, logs are good, but it's tip of iceberg. pgMustard statements is a very good way to control almost all. It has like 5,000 limit in terms of normalized queries. Sometimes it's not enough, but still, like you see almost whole iceberg. But without examples and without plans. So still logs are good for examples. I would choose pgMustard activity with increased track size. I don't remember. It's 1024 by default. Usually what you want is like to put 10,000 there or so and see real examples to sampling from pgMustard activity. But where to get plans? Right? This is the big question, because if you want to gather samples of plans or some maybe even more like normalized plans and understand what's happening, auto-explain is the way to go still.
Exactly. There is go on.
I think in the future we will have some generation 2 tools, maybe based on the BPF, by the way. Maybe some some extensions. But right now, this is the best way to collect actual plans, auto-explain. That's why it's so important, and many people want it. That's why.
Yes, I think it's the only way of running your queries, getting the output of your queries, and also logging the plan. So it's like you can't, if you run explain analyze manually, the queries run, but you don't get back the results. So it's an interesting like best of both worlds there. There is
I don't get it. Auto-explain don't log results. It logs query body and plan.
It doesn't log them, but whichever client like requested that. So let's say you're running queries in client A over here. It's getting results back from those queries, and separately we're logging the results. Whereas if we start up a session as client 2 and run explain analyze on one of those queries, we get the plan back, but we don't get the query result, right?
I see. If you So if you request explain analyze, you say I want plan but not results. But sometimes you want both. Yeah, it makes sense.
Yeah,
it makes sense.
So that's
and you can play with parameters of auto explain in your session and say, okay, now in this session I want all queries to be logged by auto explain with plans, with timing, with buffers. Let's go, like full, like tracing all plans, and then you work normally, obtaining results. It can be some application you use, right, or just human who is working with database using SQL. And for this session, we log all plans because we want to understand what's happening, right?
Yeah, like let's say, for example, you have something that's intermittently slow and you can't work out why it's intermittently slow. You run explain analyze 10 times and it's not slow in any of those. But then when you run it via your application, 1 in 100 is slow. So how do you know when to run explain? Like how do you reproduce that? Auto explain is a really good way. In terms of the V2 of pgstat statements, that's a really interesting topic and not one that I prepared for. But there is that extension from Percona that they're trying to replace, and I think that does sound.
I would consider it as V2.5, not V3, but V2.5.
Nice.
Yeah, because it has more things than pgMonitor, right? pgMonitor, pgstat monitor.
I'll get the correct name and I'll put it in the notes.
It's replacement for pgstat statements. Very promising, interesting, but I think like to become popular, we need to check its overhead. It's very interesting. I would like to learn more about it, and also probably it should be in contrib modules.
I suspect that's their goal long term.
I talked to them when they started. I talked to Peter actually and asked about this particular decision to instead of improving pgstat statements to work separately. And one of the reasons was obviously independent release cycle, because if you want to improve something from contrib modules, you understand that release cycle is 1 year, and you need to convince a lot of people and experimental things and so on. It's hard to get into it, right? So it will take years to build something very breakthrough because it's hard, yeah. But separate, you can move faster and do many things.
I think it's a smart strategy. So you've mentioned overhead a couple of times, and I think this is a really interesting area, not just for auto explain, but for a lot of these, like a lot of things we've mentioned. I have looked in the past and tried to find some even basic benchmarks of the overhead of things like pgstat statements, auto explain, pgstat monitor, anything like this. I'm just interested. I understand that, but the flip side of that is that in quite a few places, people mention horror stories, or there were really severe warnings in the docs saying, for some of them, not all of them, that the overheads that can be really massive, so be careful. But no one ever kind of says how much it is. And then if you go digging in the mailing lists, every now and again you see either, like, some people mention a few percent here or there. One person mentioned like 2 or 3x overhead. So there are some really scary stories out there. So that was the time.
It can be killing overhead if you don't use logging collector. If you use syslog with journal D, well, maybe it's improved, but like I benchmarked it like many years ago. But and then you say threshold is 0, meaning that you log everything. I think you don't even need to track timing and buffers. It will be enough to kill your system just like that. So speaking of benchmarks, let's be a little bit in the context. This week, yesterday actually, AutoTune published an article saying the worst thing in Postgres is MVCC. They hate it most. Well, I understand, but I digged into underlying research, and there is a paper, like scientific paper, comparing MVCC in various systems, and it doesn't provide any discussion, any numbers, like how exactly they tuned AutoVacuum, for example, and so on. So details are very important here. And we all know, like, it should be written on the front page of postgresql.org that defaults are very old. don't use defaults. Defaults are very old. Don't use defaults, right? And you do need to tune it. Unfortunately, this is Postgres. You do need to tune it. You need to understand some things, and you need or probably help from expert and tune it, right? So auto explain is great thing, but of course, if you enable, like saying auto explain is bad, it's the same as saying log min duration statement is bad. They both are bad, but they both are good. Let's talk about overhead. There are maybe 3 places where I see overhead. First, we already touched actually. First is logging and disk I/O overhead. So if you log too much, since you log to disk, it's not good, right? If, for example, if you logged into some, by the way, I did it in some like TMPFS, like into memory, small disk, but very, very quick rotation, understanding risks that it can be saturated in terms of space. But if you rotate it very, very quickly and send details to offload it to somewhere, you don't touch disk at all, you can log everything in this case. It's possible to use it. Here I would blame Postgres for not having some easy ways to not to log to disk. I would rather, for example, say it over UDP to some different place, and that's it. Just send logs. And in this case, we would log much more, and just network would be our probable bottleneck, right? So, right. But if you log to disk, as we do in most cases with Postgres, so this is number one thing to consider. And sometimes people have logging logs. They store logs on separate disk, and I saw several times that this disk is magnetic. So yeah, so this is easy. Like you can shoot your feet very quickly here, your legs. Right?
Yeah.
So this is number one. Number two, CPU, right? CPU. Maybe you can tell more here, like how to measure.
So there've been good blog posts in the past about, like one from the Ongress team around. Yes. So he said, "Explain, analyze, can tell you lies." Yeah, exactly. It's a very good title, but the main point he has is that if the track timing calls to measure timings, if you're running explain, analyze with timings, which is the default for explain, analyze, then the fact of measuring them, so there's an observer effect. The fact
classic
you're measuring,
observer effect.
Yeah. And
once you measure it, it's changed. You measure something else already.
Yeah, exactly. So the timing's reported, and so the query will be longer because you're measuring it. Now,
but it depends on CPU, right? On Xeon, for example, modern Xeon like Cascade Lake, for example. Well, relatively modern. It's not that bad if you check it.
No, there is a tool within Postgres. I'll link it up in the notes, but I think it's called PG Test Timing or PG Track Timing, something like that.
In bin directory. Mm-hmm.
Yeah, and you can. It's very quick and easy to check if yours is like relatively fast. The only place in recent time that I've seen a not well performing one is when somebody was running Postgres in Docker, and most production systems I've seen are run on sufficiently decent hardware that it hasn't been a big issue. But I do trust that there are very well respected people who do recommend turning timing off when you use auto-explain for this reason, and I think it's mentioned in the docs still as well. So I suspect there are cases where people are still running production systems, or there were workloads where I think Alvaro mentioned like nested loops having a particularly high like overhead, for example. So if you have a workload that has lots of loops that do things in the tens of thousands, hundreds of thousands,
so for some
probably not good query plans, but it's possible that for certain workloads, possibly, yeah. Now it's I think, for example,
I wonder what's overhead on ARM, like Graviton 2 and so on. Like, have you seen any?
I think I've published the only blog post on this that's ever been published. Like, I would love to see more on this, but I haven't seen any.
It's good. It's a good area to research. Definitely interesting.
I think it's interesting, but based on the reaction I got, which is like it's just a comment from you and nothing else, I think there's limited interest in this for some reason. And I've seen quite a few production systems with auto-explain on, sample rate 1, min duration 100 milliseconds, and timing on. So, and not just timing, right? Buffers as well. So I think this is like you mentioned it's not just. I think you saw in the past that buffers might have a small overhead as well.
Buffers definitely have overhead. If you run, like, if you say explain, analyze timing off, buffers off, you see, I mean, manually, right? And you can do it the same with auto-explain. You get rid of timing and buffers overhead. And you just, it's also already useful, right? Because you see structure of the plan. And you have total timing because it's already calculated. It's like similar to log min duration statement log entries. So it's already useful to see structure and just total timing. Good. But then buffers and timing, I would choose buffers. They have some overhead. It's also interesting to understand for your system and for your queries what it is. But buffers numbers in this podcast are honored. We have timing already, right? For overall timing.
If we don't have to choose one. We don't have to choose for either or, though, right? Like we can get both.
We can get both, right? But let's agree on this. Even if someone performs very good benchmark of overhead of auto-explain, I would consider it as valid only for particular system, particular workload. That's it. In each particular case, if we are serious guys and we want our system to be reliable, performant, and like scalable, handle growth and so on, we need our specific benchmark for our workload, which is very interesting topic and hard to. We probably also need to talk about one time, and for our hardware, for our Postgres version, and so on and so on. And in this case, we should measure two overheads, from buffers and from timing. Right?
Yeah. Well, in very simple.
And consider 4 points, like without anything, with both, with only timing, with only buffers. Here I would exclude with timing only. Because buffers, in my opinion, in terms of internal metrics inside the query, buffers are more important than timing numbers. What do you think?
More important. I think it's like an argument for the sake of an argument. I don't see it as an either or. Like if timing overhead is not worth it for your system, if it's too much, don't track it, and buffers are useful. But would I, like, if I had the choice of just buffers or buffers and timing, I would choose buffers and timing. Like I'm never in a situation where it's a choice one or the other. I've not seen, like, if they had similar overhead and if we could afford one but not the other, sure. But I've never seen that, and I can't imagine it's true because, for example, buffers aren't, like, timing's tracked per loop, right? But buffers are reported not per loop. They're reported per per node. So I wouldn't be surprised if it doesn't have the same looping overheads, for example.
Interesting.
And there are no warnings about it in the docs. So anyway, yes, sure, in principle, I think you're probably right, but I just haven't seen that be a practical question ever.
Interesting. Okay, maybe you should enable both and have sampling. It depends.
Maybe, right? But if you do check this on your system, I'd love to hear, even if you can't share details, I'd love to hear, like, what order of magnitude were the overheads? Like,
I have it enabled in a couple of places, actually, quite loaded ones recently, but we didn't do, somehow I missed this. We didn't have, it doesn't follow my principles. My principle is always have some benchmarks and make changes based on numbers and so on. But since it was enabled with like some quite low sample rate, I mean, like below 10%, for example.
Yeah.
It was considered as low risk and threshold and sample rate. So, like, let's have something, right? We already have something already useful. We didn't discuss it, but one of the use cases, probably maybe very important one is when we enable it, and if we have big teams, we use this as to support their work on optimization, like continuous optimization. We say, okay, these are bad slow queries, and we have examples for with plans. Look at them. And in this case, if you enable it above this like 500 milliseconds threshold duration, and also sampling 10%, enable both, right? But it's very bad if we do it blindly. We need to run benchmarks and understand what's the price here. How would we do it in some system? For example, we have some system, OLTP, and we want to measure it. How?
We did a whole episode on this, right? Like benchmarking.
Well, yeah, but this is specific benchmarking. First thing I would do here is to ensure that we don't have overhead from observer effect from logging system, right?
So the test our timing.
We should separate these things, and benchmark should not hit, bump into this ceiling, right? We don't want to saturate our disk I/O and then make conclusions. Like, to explain is 10x. This is how you can do it very easily. So you need to make sure that you have room in terms of disk I/O, and then you can start thinking about overhead. Well, probably I would run two systems like exactly same, one with auto-explain, one without, and I would probably like make sure I don't saturate anything at all. It means that probably I would do it in single session. I don't need multiple sessions here at all, which means that it's possible also to run it on some non-production environments like database lab engine, for example. You can just compare and see, like infrequent queries, like single session, run this query, run that query, and compare details.
Probably latency mostly.
Yeah, latency, right? But do it many times with the same query.
Yeah.
To eliminate
or a workload that you can replay on both, right? Like,
right. So you don't want to reach the edge in terms of CPU and so on. It's still performance experiment. It's performance research, and you repeat same queries many times to have reliable data, and then you just compare without it and with it. What's the difference? Latency probably the only. Not the only. If we have what else we have? We can have pgStat statements enabled and check not only latency but also buffer numbers. Well, buffer numbers should not change, right? Because we execute.
They shouldn't.
They shouldn't, right? What else? Probably wait event analysis would be applied here as well. Maybe. Like I'm trying to invent something on the fly, but definitely latency is the main point here.
Yeah. Well, yeah. I guess
the main danger the main danger in this benchmark is to bump into some different limit, like disk I/O or anything else, and measure it instead of real overhead from auto-explain.
Yeah. Even I fell into that trap in my blog post I was probably doing far too high workload for the machine I was running it on, and I also tested the logging overhead, and on my system there was about 25% overhead just from logging everything, and then I turned that off and it got it down to it was less than a couple of percent.
By the way, eBPF analysis would be great here, and you should see that overhead comes from auto-explain. This would be the best if you you measure for this type of query, we have 5% overhead because we know this query executes with nested loops, for different parameters. By the way, different parameters in pgStat statements, we have one query, but with different parameters, we have different plans, right? So we can have same query, but depending on parameters, overhead may be different because plans are different.
Yeah.
So parameters also define the plan, and of course, we need to take care of planner settings and work mem and so on. I mean, this experiment can be done on different hardware. CPU should be the same, but I don't care about disks unless they are saturated. If we don't saturate disk I/O, disks can be the same. File system can be different file system. That's why ZFS and database lab can work. But course, CPU course should be the same. Postgres version should be the same. Planner settings should be the same. And then we play with queries in single session and compare. Interesting experiment, by the way. Yeah. And if we have ability to check with a BPF where, like, to perform an in-CPU analysis and see that indeed, like 5% for these particular queries, 5% overhead for these particular queries with particular plans, 5% overhead comes from auto-explain, this is success.
So you mentioned 3 types of overhead. I think you said disk I/O for logging, for example, CPU for timing. Was there a third?
CPU for buffers.
CPU for buffers, yeah, makes sense.
Yeah. Well, what else? What about additional memory? Probably no, right? What about network? Probably no. So I don't see any. Maybe if there are some other types, I just don't see them.
No,
Yeah.
there are a couple of limitations I wanted to make sure we covered that I've seen catch people out in the past. One is that it doesn't track planning time. So these timings are all about execution times, and there's no reporting of planning time. So if, for example, your client is reporting that a query is taking 1.1 seconds and it's only a couple of hundred milliseconds in auto-explain in the logs, the difference, I mean, you can verify this by running explain analyze, is chances are it's a very high planning time overhead.
Well,
and I guess that's another argument for...
We have it since Postgres 13, we have it in pgMustard statements, planning time. And
nice.
Yep. And of course, like, it would be interesting to dive into, like, auto-explain power is the execution tree it shows, right? It would be interesting to dive into planning time for particular nodes. Like, it's not possible. Planning time is a whole, and as a whole, we have it in pgMustard statements. If we divide it by calls, we have average planning time and so on. Actually, we have it there, like mean, max. It's there. It's tracked there. So
I think this might be another argument for the log min duration. What's the other setting? The logging one we were talking about having both on. I think that one does include planning time.
That's interesting. That's interesting.
So any difference there? Anyway, so that's kind of a bit of a gotcha. Another small difference is that, and I think this is coming in Postgres 16. I saw a commit for it. Is it doesn't currently log the query identifier, which can be really useful. Even if query ID, auto-explain currently doesn't log it, even if you use verbose, which is the parameter that adds the query ID in explain. So that's another, like, minor difference between them.
And the log min duration statement does it, right? Query ID.
Yes, good point. Another reason.
Yes, I remember in some version
14, I think.
14, yeah. We have, since that version, we have query ID matching pgMustard statements query ID in both logs, slow log. We call it slow log, but it's not separate, unfortunately. And in pgMustard activity, right? So we can basically load it to some tables and then join them and have quite good analysis. And some people do this. Right? Yeah, that makes sense. Interesting.
And one other thing I forgot to mention that is different between them is that in auto-explain we have an extra parameter which is log nested statements, and that's another use case for this. We don't have access to that when we run explain. For example, doing function, like I know a couple of people that use a lot of.
You go already too far, right? So I think for like I saw discussions on Twitter the last couple of weeks, and there are different approaches. Some people say no, not on production, but some people say yes, and I actually say yes, just carefully. Right?
I like it, measured.
But details, it's slowly to like. Oh, by the way, sampling is very interesting. I didn't realize it until like maybe a couple of years ago when you wrote this article. That sampling exists for many versions already, unlike query logging, for which sampling appeared in 13 or 14 only, like a couple of years ago. In auto-explain, it exists for many years and many Postgres versions, so we can benefit from, for example, in Postgres 12 or 11. So,
all supported versions of Postgres for sure. Possibly some even.
So it's
old
great.
ones.
It's great. Like I like sampling in heavily loaded systems. Even if we concluded that we have overhead like 50% or 100%, we still may decide to have sampling at least like 1% of queries because we need this information. We will. Of course, if we use it's better if we have overhead, we enable it and nobody is using this information. But if we do need it, it's okay to pay some price, right? In some cases, and have this very important information to optimize our system.
Completely agree.
It will pay off very quickly.
All monitoring of any description has some overhead, right? Like we can't monitor at all, and most people think monitoring is a good idea. So then the question becomes, how much overhead is worth it for the benefit?
Yeah, observers and observer effects are everywhere.
Yeah. Wonderful. Shall we call it a day?
Yeah, I think it's like summary is that measured on your system. Be quite optimistic. I think like fears are discussed around, sometimes go from not understanding where it can hit you, right? And if you understand where it can hit you, you will be fine. Like Disk.io and this, like we discussed it, and sampling, and so you can be good. And even if overhead for your system is quite significant with sampling and high threshold, you can still find it very useful because plans are a very good thing.
Yeah, and don't set log min duration to 0. That's my final parting advice.
Right. And don't send queries as is to ChatGPT. and plans also. Don't send plans as is. Yeah.
Nice. All right. Well, thank you, Nikolay. Thanks, everybody. And see you next week.
See you. Bye.